Hello guys, welcome to JLC Java Learning Center. This is the day one of your Java session. I'm Srinivasdande, your trainer for Java and all the technologies. So in this introduction session, we'll start with fundamentals of Java or the first module, Introduction to Java. In this, we'll understand all internal things, Java installations, setting up paths, writing programs, first program, compiling, running, all this we'll see in the first module called Introduction to Java, right? So we'll start with very basic fundamentals. So all of you are having computer. It may be a desktop or laptop, right? So what are the important parts of a computer? What are important parts of a computer? Very good. One is CPU. Important. Many parts will be there, guys. You have a keyboard also, mouse also, keyboard, mouse. Fine. But very important. I want a key. So one is the processor, right? Processor is like a brain. Your brain is not there, nothing, right? So first part is the processor. Very good. And then RAM. Second is the memory, right? Operating system also okay. Required other input devices like monitor, keyboards. I'm not considering at all. Motherboard also I'm not considering. Next very important part of your computer is memory. Memory. RAM in laptop. Not only in laptop, Ramesh, RAM is required for any device, whether it is a laptop or a desktop or a palm tab, or it may be mobile also. If you are using a mobile also requires a RAM. RAM is required for every electronic device to process. Okay, second is memory. So stick on to memory. Second important is memory. What are the types of memories available? What are the types of memories available? What are the types of memories available? RAM and ROM. Very good. Primary and secondary. Wonderful. So primary is the RAM, right? Primary is the RAM. RAM is a primary. And secondary is the ROM. ROM you can also call with another name. We are in a regular life, we will use a different, temporary, permanent. RAM is a permanent, RAM is a temporary, ROM is a permanent, secondary. Right. Now, another name for ROM, another name for ROM. Is that your hard disk, guys? Is that your hard disk? HD. Right, that is your hard disk. So in your computer or laptop, there are many devices, but I'm considering only these three key sections which will help us to run your program. Why we are taking only these three now is, we are going to write a program and we are going to run the program. Whenever you run the program, internally, how these three will help us? How these three will help us to run the program? Now I'll take a simple C program. I hope everybody knows the C language. If you don't also know worries, just follow me. I have written one C program called hello.c. Some code inside that. So I have written a C program called hello.c. After writing the program, what I have to do? After writing the program, what I have to do? What I have to do after writing the program, guys? Can I execute directly? Yeah, I written means I saved it. I written and saved. Then you have to compile. Very good. Very good. Who is that? Abhishek and Sai. Shravani. 3 compiling answers. Very good. First, you have to compile this program. After compilation, what you will get, guys? After compilation, what is the output? After compilation, what is the output? After compilation, what is the output of the program? You will get another file. You will get another file called hello.exe file will be generated. One exe file will be. It is not Java Lakshmi. We are talking only about a C language. We'll go to the Java next. Let first understand this. So, no bytecode puja at all here. This is not at all a Java. This is only C language. No Java in this, right? So first you are writing a C program. C program contains high level code. C is a high level programming language. It contains high level code in a C language. Then you are compiling this. Then you compile this. After compilation, you will get exe file. In the exe file, exe stands for executable. The code inside this is executable code. You can also call it as mission code. You can also call it as binary code. You can also call it as binary code. Mission code is inside the exe file. Binary code means mission code or binary code. Mission code is the code that should be, or you can say mission understandable code. Machine means what is the machine here? What is the machine here, guys? What is the machine? Is that your processor? Is that your processor? Machine is a processor, right? Machine is a processor. And machine is an electronic device. Machine is a processor is an electronic device. So what languages electronic device knows? Maybe you know English language, you know maybe Telugu or Hindi or some language, right? So what electronic device knows? Your machine knows only the binary language. It knows only the binary language, binary code. The language itself called as machine language or a binary language, that is just in the form of ones and zeros. Ones and zeros. Machine understandable code is the binary code. So you are getting exe file. Okay. Next. Next question to you. Why we have to compile? What compiler is doing? You are using a piece of software called compiler. You are using a compiler to compile the C program, right? Now, what is the goal of compiler? What compiler does? Nagaraju is telling errors, errors, errors. Very good. Compiler has a 2 jobs, guys. Compiler has a 2 jobs. 1 and 2. Number 1, check the grammatical errors, check the errors, syntax errors, whatever you write, because you're writing the C program using C programming language syntax. C is a programming language. It has some standard syntax. Grammar is there. Syntax is nothing but in our general words, grammar, right? So any grammatical mistakes in your program, compiler will try to identify and shows, boss, you have this many mistakes you have done. All the list will be displayed to you. And if once the mistakes are corrected, if no mistakes, no grammatical mistakes, no syntax errors, then it will translate your source code to machine code. Very good. Second is convert to machine code. Convert to machine code or binary code. Very good. So after getting the binary code, after getting the machine code or binary code, what we can do, guys? What we can do? Now you can run this program, right? Now you run this program. You can run this binary code only. You can run this binary code only. You can run this binary code. So what happens when you run? That's what we have to understand. So till now what we have done, we'll recheck again. So first step is I have written hello.c program and saved in the hard disk. Where I saved this? I saved in the hard disk. For example, I am taking a D drive in my hard disk. In D drive, I am saving the program as hello.c. After that, Abdul, binary code is not human understandable code. You can't understand the binary code at all. Binary code is machine understandable code, not the human understanding code. Okay? Come back. So first I have written hello.c. Then I am compiling. If I don't have any grammatical mistakes, I will get a binary code or a machine code. It will come in a separate file here. Separate file called hello.exe. Now where the exe file is saved? Where the exe file is saved, guys? That is also in the hard disk. That is also in the hard disk. I written a C program, saved in the hard disk in the D drive, and I compiled it. I got hello.exe file. That is also saved in the hard disk in the same drive, same folder only. Now, when I am running this, what happens? When I am running this, what happens? When I run the program, what happens internally? This is what we need to understand very clearly. That will help us further in many of the memory management techniques internally, what happening. We'll see many things so deeper. This is required for us. Tell me, guys, when you run the program, what happens? Or the same question I'll ask you in a different way. When processor will involve in this game? When processor will involve in this game? When your RAM will involve in this game? How the processor will be utilized when you're running the program? How the RAM will be utilized when you're running the program? I am running my hello program, guys, which is hello.exe file I am running. It displays the output finally it has to display the output. that anybody will tell. Hari Shankar, yes. So what is the use of RAM now? You are using a RAM in your mobile, desktop, laptop, everywhere. Why RAM is used? Prasad, it is already, Prasad, it is already, say, already I have written a program. You listen my points very carefully. Already I have written a program and saved. Already I compiled. So my grammatical mistakes not there. Assume. Then it is already converted to hello.exe file. Right? Already compiled. Already binary 1 and 0 generated. Binary code generated available in exe file. I am running the exe file only. Now what is happening? Is, yeah, one guy has answered. Harish Shankar has answered. See what happens now is the first job. Now understand about the RAM, guys. Any program, okay, I understand that you don't know about this. I understand that you don't know about this. Come back, listen. What is the use of RAM? And what is the use of processor? First, listen carefully. Don't type anything. Listen carefully. Processor will execute your binary code. I'm writing, read it carefully. Processor will execute your binary code. Okay. Now, what I am executing? Hello.exe file. What it contains? It contains the binary code only. So my processor can execute this binary code, right? Processor can execute this binary code. But processor will read the binary code only from the main memory. Currently, where is your exe file? Where is your binary code, guys? Where is your binary code? On the screen, you see where is the binary code? In hello.exe file. In hello.exe file. Where is that? That is in the hard disk. Your binary code is in the hard disk, right? So whether processor will read the binary code from hard disk? Whether processor will read the binary code from hard disk? No. Processor will read the binary code only from the RAM, main memory. So what happens? Whenever you run the program, first job is it will copy the, whenever you run the program, task 1 is copy the binary code to main memory, which is your RAM. So you are running, you have a exe file here, right? This exe file binary code, the binary code will copy to RAM. Suppose it has a 5 lines of code. So the line 1, line 2, line 3, line 4, line 5. It will copy this here. Step number 1. After copying the binary code into the RAM, then your processor starts reading binary code from RAM and executes the binary code. Now your processor will start reading from here. Processor will read this, executes the line 1, whatever the line 1. Suppose the line 1 you are reading the data from keyboard. It is asking enter the 2 numbers. You enter 2, you have to enter 2 numbers. Your processor will read it and you have a sum of 2 numbers. Finding a sum, it will do all the lines, it will execute, final output will come. You will see output, you will give input, you will get output. Program goal is every program you write in any programming language in this globe, it will take the input. Program takes the input, process that and produces the output. That's the high level. But internally, your processor will read from the RAM or a main memory and executes that. So whenever you execute a program, whenever you execute any program, your processor has to execute the code internally. So processor will read only from RAM, not from your ROM or hard disk. So your code in the hard disk has to be copied to the main memory or the RAM, then only it will execute that. So is that clear about processor jobs and RAM jobs? Is that clear, guys? Very good. Nowadays, processor means how many processors are there in your computer? Nowadays, or you see in your computer, my simple question to you, do you have 1 processor or 2 processors? Or 3 processors? Or 4 processors? Or 5 processors? Question is, about the RAM. Alaikia. Okay, listen it carefully. RAM is primary memory. Why we are calling a primary memory is, if processor wants to execute any piece of code, if processor wants to execute any binary code, processor has to read from RAM only. So when you run the program, see these lines. What happens when you run program? That is my question to you. What happens when you run the program? Whenever you run the program, initially, where is the program code? Running the program is you're running the executable code only, machine code only, binary code only. Where is your binary code? Hello.exe, which is in the hard disk, right? So first, the binary code has to be copied from hard disk to main memory or RAM. Copying the binary code from hard disk to RAM. Then processor will read the binary code and execute binary code from RAM. Processor reads the binary code from RAM and executes the binary code step by step. So RAM only stores the whatever processor executing, only that code will be in the RAM. For example, I have 1,000 programs saved in the hard disk, guys. I have 1,000 programs saved. How many programs are there? I have 1,000 programs saved in the hard disk. Means I have written 1,000 C programs, maybe 1,000 Java programs or 1,000 Python programs. This is applicable to every programming language. So I have 1,000 programs, maybe written in any programming language, no problem. All programs are in the hard disk. Now my question to you guys, will it load all the 1,000 programs into RAM? Will it load all the 1,000 programs into RAM? No. Then what programs will be loaded into RAM? What programs will be loaded into RAM? What programs will be loaded into RAM? Or which program will be loaded into RAM? Whatever the programs you are executing, right? Whatever the programs currently you are executing, that program only will be loaded into whatever the program you are currently executing, only that program will be loaded into main memory. So can I say main memory contains RAM contains currently running program. What program will be loaded into main memory or RAM? Currently running program will be loaded into main memory. Is that clear? Now, extension to this. My question to you guys, how many programs I can load into RAM at a time? How many programs I can load into main memory at a time? All of you are answering one, only one. Okay. I'll answer this question again, or you only will answer it after some time. Come back. So come back to the previous question. How many processors will be in your computer? What is your processor type in your laptop? Tell me that. You are using Intel only, right? Intel processor, right? Is that i5 or i3 or i7 or i9 or what is that? i5, mostly i5, i3. Now tell me, how many processors are there in that? How many processors in i5, guys? Okay. 4 processors. Durga. So, yes. What is the dual core? Intel, you take, consider, there are many types of processors nowadays. Octa core, yes, Muhammad. I think you are using the terms now. Have you heard the revolution of the processor engines? How the processor engines, once upon a time, guys, there is only one processor in your computer. Later, they introduced a dual core, means two mini processors are there in that. Dual means two processors. After a dual, you have a quad core, four mini processors running in your computer. And later introduced octa core, eight mini engines running in that. Eight mini processors running means you consider as a individual processors only, right? And hexa core, if you take 16 processors, mini processors running in that. In the processor, whatever the hardware they are fixing in your system, it contains the 16 mini processors. I'll take octa-core processor. I think i5 has octa-core only. I'm not very sure. A doubt only. Let me to have my system. What is there? I don't know. My RAM is 16 GB. This is i7, guys. This is i7 machine. Let me check. We can find it in a Java program. We can write in a simple Java program and find it. Just sit there 1 minute. We'll go back and do that. That is the machine code. Somewhere I written the program. Yes, you see this program. This gives you how many processors running on your computer. Just have a look. Mine is i7. .615, right? Java C lab 615.java. Just compiling this. You don't worry, I'll explore all this. We didn't start. This is something I'm running just to see the number of processors. So what is the number of processors showing? If you see the piece of code we have here, this is the first line. Runtime available processors. How many available processors? I'm asking. How many available processors are there? It is showing 8 processors available. And what is the total memory available? This is a RAM memory. How much RAM is there? That also RAM also we can find it. How much RAM, max RAM, right? This anyway we'll explore the memory management later. That's what we need, this internal basics. Come back. So we want only the processor related information. So you understand, in my machine 4 are there. And if it is i5, maybe you can have 8 or it is a quad core also, depending on. I am simply considering currently for easiness to draw the diagram. You are using a quad core processor, guys. Mine is the 8 processors, means octa core processor. 8 means octa core processor. Assume if i5 or i3 something, you are using a quad, QUAD, quad core processor. Means 4 engines will be there. So how many cores are there? This is the core 1. This is the core 2 and this is the core 3 and this is the core. 4 cores are there. What is the meaning of cores, guys? Core is a processor. You call it as a processor engine, mini processor. How many processors are running in my computer, guys? How many processors running? 4 processors running. 4. In my system is not my original computer. As per diagram, you tell, please. As per diagram, how many are there? Core 1, core 2, core 3, core 4. I have a quad core processor. Quad core processor. So 4 engines are there. If four engines are running, how many programs I can run concurrently? How many programs I can run, guys? Yes, I can run 4 programs. Practically, you can run even more than 4 also. You can run 40 programs also using the 4 engines only. That we'll see in the multi-threading or a multi-processing or a multitasking concept. With the 4 engines, you can run 40 programs also. There is a mechanism for that. We will talk in the multi-threading concept. Basically, at least, I have 4 persons, guys. 4 engines means 4 persons are there. With the 4 persons, I can do 4 tasks, right? Each person can do 1 task. So I can run 4 programs. How many programs I can run concurrently? How many programs I can run concurrently? 4 programs I can run concurrently. Now my next question to you guys. How many programs I can load into RAM concurrently? How many programs I can load into RAM concurrently? It is 4, right? Previously asked the same question, you told as a 1 only, right? So if I am running 4 programs, I have 4 processors to process. So I can run 4 programs. It means concurrently I am running 4 programs. These 4 programs, whatever I am running concurrently, 4 has to be loaded into main memory. Exactly. RAM is only for that purpose. Now, sometimes you will see this is same process in your mobile device also, guys. Sometimes your mobile device will hang or your laptop will hang, your computer will hang. Can you say the reason why it will hang? Can you say? Whenever your system hangs, you will restart. Whenever your mobile hangs, you will restart the mobile. This is what you do, right? But why it is hanging, guys? Because of less RAM. Am I right? Less RAM, okay. But what is the problem coming up? What is the problem coming up? And don't use the big word deadlock. No deadlocks, nothing. Simple solution. Simple solution on the screen. For example, what can be your RAM size? I have a 16 GB. Maybe in your machine you have 8 GB of RAM. Consider 8 GB of RAM, guys. You have 8 GB of RAM available. You have 8 GB of RAM available. I am running so many applications. What happens? I am running so many applications. I am running so many applications. Whatever application I am running, whatever the application I am running, the application related code has to be copied into RAM. I am running the application 1. It loads into RAM. Again, second application I am running, it loads into RAM. Third application, it loads into RAM. Fourth application, it loads into RAM. Fifth application, it loads into RAM. Sixth application, it loads into RAM. Your RAM has 8 GB only. Once the RAM is full, what happens? Hang. You are running another application. There's no space to load into RAM. If you are unable to load any application onto the RAM, you can't run that. Understand, guys? Clear? Super clear? Wonderful. Now, we have processor. It can have multiple engines called a cores, and it may be a dual core, octa core, hexa core, like this. And depending on that, we can run a number of programs. Whatever the programs we are running, those programs related binary code will be copied into the RAM, and those only will be executed by the processor. And your processor can understand only binary language, mission language. Processor can understand only binary language or mission language. Processor don't know English. Processor don't know Hindi. Your processor don't know Telugu. Processor don't know Kannada, don't know Tamil, don't know Chinese, Japanese. These all languages your processor don't know. Your processor knows only one language called mission language, or the binary language, which is nothing but ones and zeros. You write everything in ones and zeros, only it can understand that. Right? Very good. So now come back to another case. So now you are learning Java language. Now you are learning Java language. So when you are learning Java language, what you do? You write a Java program. You will write a Java program. Fine. You have written a Java program. You have written hello.java. Your first Java program you have written, guys. This is called as a source code, right? Source code. Source code, in which language you are writing source code? Maybe hello.c, also source code. Say this point. Hello.c or hello.java, or you are writing in a CPP, hello.cpp, or you are writing in a Python, hello.py, Python extension is py, hello.scala. Like this, you write any program in any programming language, and also Go language. Go language also is there, right? Go, Kotlin, there are many languages. Now you write the code in any language, that is called as a source code, guys. You write a Python code first, source code, that is a source code. C++ code, C code, Java code, whatever you type, that is called as source code. In which language you are writing source code? In which language you are writing source code? English, right? English. English only. English. English. You are writing in English. You are writing in English. If it is Java program, you are using Java grammar, Java syntax. If it is C program, you are using C syntax. If it is Python program, you are using Python syntax. If it is Go language program, you are using Go syntax. Syntax will change depending on the programming language. But the letters you type is in English. Am I right? Now, can I run this program directly? Can I run this program directly? Can I run this program directly? No. Why? Why? Because this is written in English language. Your processor don't know English language. Correct? Your processor don't know English language. Okay. We need to compile this. Compile. You are compiling Java program. After compiling Java program, what you will get? Again, we are using a Java compiler here, right? Previously C compiler. Here Java compiler to compile the Java program. So it will produce hello.class file. Very good. I think some of you have mentioned this. What dot class file contains? Dot class file contains the bytecode. It contains the bytecode. So what the compiler is doing again here? What the compiler is doing, guys? Compiler tasks. Compiler tasks. Any compiler, first task is check errors, check syntax errors, right? Check syntax errors. And then convert it to binary. Is it Bhavanu Prakash? Is it converting to binary here? Your source code is converted to binary in Java. In C language, previous diagram you have seen, in C language, your source code, C program contains source code that is converted to the binary directly. But here it is not converting to binary if you see my diagram. Sandhya, Harshini, your source code .java converted to .class. In .class, what is there? Byte code is there. Is that a binary code? Whether byte code is a binary code? Whether byte code is a binary code? Whether byte code is a binary code? No. Means now whether compiler, Java compiler is converting, whether Java compiler converting to binary code? You are not getting a binary code at all. Now can I, this is a byte code, guys. Whether my processor can understand this byte code, whether the processor understand this byte code, very good. Still processor don't know this. This is some language. This is not a plain binary. Plain binary means 1001, 1001. That is only the plain binary. Your processor, an electronic device, can understand only on, off, 1010. It can't understand anything. This byte code is not a binary code. Remember, byte code is not a binary code. Byte code is not a processor understandable. This is not a machine understandable. This is not a machine understandable. Pooja, you will get it. You will understand it. After some time, you will understand. What's the difference between binary code and byte code? You will understand that very, very clearly. Give me some time. Now, okay, we have to finish these tasks first. Compiler tasks, please. Come back to this. Stick on this. What is the compiler task? First is checking the errors, syntax errors. Next, second, guys. What is second task of your compiler? Second task of your compiler. Just now we have seen C compiler related. First checking the errors. If no errors, then converting here. Convert your source code to what? Source code to byte code, am I right? Because it is Java compiler, Java program. Java compiler converts your source code to byte code, not the binary code. But Java compiler is so intelligent. Java compiler is intelligent compiler than C, C++ compilers. Java compiler does code optimization also. Java compiler does code optimization also. What is the meaning of code optimization? It will optimize your code. It will, what means whatever code you have written in your hello.java, you have written some code, right? It will try to change the code. If compiler feels maybe this is not okay, compiler will change the code into some other better code also. It is not, Java compiler is intelligent, I told. What is the meaning of intelligent? It is not simply converting your source code to byte code. It's not checking errors. In addition to that, it will see your code, whether this code can be repaired. Anything you are, suppose somewhere you are trying to waste a memory. When you are trying to waste a memory, it will avoid that. It will change the code internally. You don't know that. But I will show you some use cases. I will show you some the best use cases where compiler is doing code optimization. Means compiler will change your code without your knowledge. So sometimes the code you are writing is something, when it is converting to byte code, it will change and convert. And you don't know that. You can't understand even. For example, this is your byte code. I just shown, right? Where is the file? I closed, it seems. Okay, I'll open it quickly. This is your byte code. This is your byte code. 287 byte code. This is 287 source code is this. This is 287 source code. Source code means it is in English, you can read it. You know Java syntax, if you learn Java syntaxes, you can understand this, you can read this. If any changes happen, you can understand. This is the code, source code you are writing, and this is converted to the byte code, something like this. Can you recognize if any changes happening internally? You cannot recognize, but it does the code optimization. Compiler does the code optimization for you. How it is doing, what are the use cases, when it is doing, I'll show you some use cases on the way when you're learning the things. Okay, that I'll show you. Right. So remember, Java compiler is doing three things. Java compiler is doing three things. Number one, Java compiler checking your grammatical mistakes in your program. If any syntax errors available, it will show you, boss, you have this many number of errors. If no errors, then it will try to optimize if possible. I'm not saying always it will do optimization. Depending on the code. Already you have written a code better. Your code is better. Then no job for a compiler to optimize. If possible, it will do optimization. After that, it will convert your source code to byte code. It will convert your source code to byte code. So you have a byte code ready, guys. Compiler has produced a byte code. Now, can I run this byte code? You can run, but whether the processor can understand this, no. Now, what you will do generally after this, you run the program. Any program life cycle, two things. Any program, first you write the program and save it. So what I did, come here to D drive. In D drive, I have written my hello program. Okay. Then I compiled it. I got my hello.class file. Yes. Now I am running this program. Now, what happens when you run the Java program? What happens when I run the Java program, guys? What do you know? You just throw there in the chart. Byte code is portable. Why portable? You will understand, Navneeta. You will understand very shortly. Pooja's one question is pending. Navneeta's one question is pending. If you are not getting the answer on the way, again you come back to me. So now what happens when you run the Java program? That's you are running a byte code, right? Byte code. I'm getting the answers, converting byte code to binary code, converts this to the binary code, copy into the RAM, copy to the RAM, JVM converts the byte code and create .exe file. Okay, more or less you have written a right and wrong answers combined. Okay. See, what happens here is, first your byte code will be copied into main memory. First job is, yes, copy byte code to main memory. First job. Copy this byte code to main memory. So in this, some 5 lines are there. This is your byte code of hello.class byte code. Hello.class byte code. Line 1, 2, 3, 4, whatever byte code is there, copying this. So byte code is copied to the main memory. Now, whether your processor can understand this byte code, already I asked this, you answered it. Again, I'm asking intentionally. No, your processor cannot understand this language. So what your processor knows? Your processor knows only binary language. So what to do now? What to do now? You convert this byte code to binary code, correct? And who has to do that? Who has to do that? For this, we need another guy called JVM. we need another guy called Java Virtual Machine. We'll dig into this later. Currently, just remember, there is another Superman here, another Superman sitting here, who is responsible to convert your byte code to machine understandable code called binary code. So now this byte code will be converted to binary, guys. This converts this to binary. This is the binary code of. Now your processor will read this binary code. So what is the second step, please? Byte code will be converted to binary code. Number 2, I'm writing the numbers also here. Number 1, copy the byte code into this. Number 2, convert the byte code to binary code. Number 3, now your processor understandable code is ready. Now your processor understandable code is ready. Number 3, your processor can read the binary code and can execute happily. Now the processor executes the binary code. Now, some of you, when you answered, you told this will be converted to binary. Up to that, you have written that byte code will be converted to binary. That point is clear. But somebody has written .exe file will come. Remember, guys, here in Java, .exe file will not be generated. Whatever byte code, whatever binary code generated here, this binary code is a temporary. This binary code is a temporary. When you run the when you run the byte code, remember this. When you run the byte code, it will convert the byte code to the binary and executes that. Again, if I run, again converts the byte code to binary, again runs. Again, if I run the program again converts the byte code to binary and executes the binary. It is not saving the binary code of this program anywhere in Java. Understand? So when you run the Java program, what happening? Whenever you run the Java program, first byte code will be copied to main memory, and then byte code will be converted to the binary code, and processor will execute the binary code. And binary code generated here is a temporary that will not be saved in any file. Binary code will not be saved in any file. Now the question is, if I run the program 10 times, how many times the binary code will be generated? If I run the program 10 times, how many times the binary code is generated? That's how why I repeat the things this way, that way is same thing you guys have taken. Some people telling 1, some people telling 10 means you are taking same point in 2 different angles. Okay, listen again, guys. Listen my sentences again. When you run the program, every time it converts the byte code to binary and then executes the binary. I told the sentences just before also. Again, I am telling. When you run the program, it converts the byte code to binary and then executes the binary. When you run the program again, it converts the byte code to binary and executes the binary. When you run the program again, it converts the byte code to binary and then executes the binary. Now tell me, if I run the program 10 times, how many times your byte code will be converted to binary? 10 times. 10 times, 10 times. Very good. Every time. Because, say this. See what happens. See again what happens. Whenever you run the program, first task 1, copy this byte code to main memory. Okay. Next, convert this byte code to binary. Yes, converted byte code to binary. Then processor will execute this. Processor executing line 1 executed, line 2 executed, line 3 executed, line 4 executed, line 5 executed. So 5 lines of code is there. Consider 5 lines are there executed. Once the execution is over, remember this. Once the execution is over, this code will be unloaded. It will be cleared from memory. It will be cleared from memory. And then byte code also will be cleared from memory. Will it clear from hard disk also? Will it clear from hard disk also? It should not clear from hard disk. Hard disk is the permanent device. It can stay there for 100 years. Now when I run this program again, what happens, guys? Number 1, it copies the byte code here. Number 2, it converts into the binary and executes this. After execution completed, it will clear this, it will clear this. Again, if I run this, we'll copy this byte code again. These 3 steps will repeat every time whenever you run the Java program. Sujita, binary code will be stored in the cache memory. No caches, nothing here. No caches, nothing. No cache memories, nothing. No caches. It has to do this every time. That is how the inbuilt mechanism is done. Still, we have Ramesh, we have lots of time to go to JVM. We'll go to JVM next. This is still we are stick on to the hard disk, RAM, processor, this internal story only. We'll go to the JVM very shortly. Okay. So is that clear? Up to this is clear, guys? Okay. Done. And these diagrams, hello guys, these diagrams, whatever I'm drawing, will not be available in your booklet. I will draw so many diagrams like this on the spot. When I'm explaining, I'll draw so many diagrams like this. And it is impossible to keep these diagrams all in my booklet. So many of the diagrams will not be there in the booklet. Okay, booklet contains the main points plus the programs. So what you do, once the session over, you will get this video, right? From this video, you have to play the video, listen again carefully, write down the important points and write down these diagrams all. You buy a white book, not the ruled book, white book, one red pen, one blue pen, importantly. Then you play my video neatly, sit with a fresh mind, write down all the diagrams I'm drawing, write down all the important points. I'm asking many questions on the way, right? I'm asking the questions, you are answering sometimes right, sometimes wrong. These all questions also you write down. Okay, that's important. You will get many things, many things. Very good. Next. Fine. So we will go to another big diagram. Now we'll try to understand. You will get an access, Naveen, you will get access to all the recorded sessions. Not at given access to your batch till now, we'll give it. Shortly we'll give access and we'll update all of you guys. Okay. So as of now, what we understand what happens internally when you run the C program. And secondly, we understand what happens when you run the Java program internally. All internal story we understand. Now, and you know this, why C programs are platform dependent, Java programs are platform independent. Something you hear these terms, right? C and C++ programs are platform dependent or independent? C programs. C programs are platform what? Dependent. Very good. Java programs. Java programs are platform what? Independent. Right? So these sentences, you know, and we have to know why, big why. Why? 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 Why C programs or C++ programs are platform dependent? You just throw your sentences. Yeah, one-line interview answers, maybe you can say one-line interview answers because of Java case, because of bytecode, because of JVM, bytecode, JVM, you can say it is independent. Machine code of each environment is different and it varies on OS because the bytecode runs on any operating system. You have some points. Okay. You have points. Now we will keep your points in a one order. We will start with first C++, C++. Okay. Why? C and C++ programs are platform dependent. Mainly platform, I want to understand what is the meaning of platform here, guys. Platform dependent means depending on the platform, correct? Suppose your students are parent dependent. You are currently parent dependent. What is the meaning of parent dependent? You are depending on the parents. If you study well, you will get a job. Then you will become parent independent. You are not depending on, independent means not depending on the parents. Correct? So here it is very clear. You are depending on the parents or you are not depending on the parents. Clear. But I want to know what is the platform here. What is the platform? Navneet asked telling processor it is. What is the meaning of platform here, guys? What is the platform dependent? Platform. OS, very good. One term is OS. Yeah, OS, operating system. It can be anything, right? It can be Linux, Mac, Solaris, whatever. OS and no, I want a Pavitra. I want a clear. Software, hardware means there are those two categories only in the world, right? Software, everything is software, everything is hardware. But specific, I want. OS, you told. Many softwares are there. In that OS is software, like OS. Any other? Whether it also depends on the hardware. OS, see guys, OS and processor architecture. Processor architecture. processor architecture. These two are, we have to dig on these two, OS and processor architecture. What is the processor architecture? What is the processor architecture? No GRE here, Pavitra. We are talking only about a C++. We are heading is we are learning only C++. No Java currently. Heading, we are not talking about Java in this particular topic. This we are going to explore why C++ programs are platform or OS dependent or processor architecture dependent. Okay. So any idea what are the processor architectures, you know? Processor architectures. Again, you are telling JDK Hari, I'm not dealing anything about Java. No Java here. No Java. We are telling only, we are trying to understand why C++ programs are platform dependent. Have you studied any processors related subjects in your BTech, guys? OS is different. I'm not again asking the OS. My question is around this, guys. Second one I'm asking. This I'm asking. Processor architecture. Architecture means network of integrated circuits. Maybe no Linux. I'm not asking about processor is in hardware, guys. Please talk about only hardware. You don't have any subject like microprocessors? Ah, yes, yes. Shabina, very good. 8085, 8086 microprocessor architecture. Very good. 8085, 8086. Ah, now people are coming up. Very good, very good, very good. There are different types of architectures. Yes, yes, you are on the way. So, whether all the processors are same? Whether all the processors are same? No, right? So, if I generate a code in one processor, you just take this point. Yes, you are on the way now, right? You understand a processor types. You understand a various different processor architectures means you have different types of processors. And the internal architecture of the processor is different. Suppose I have something called 8085 processor, guys. This is very old processor only. We have very latest advanced processors nowadays. Now I am generating the binary code on this processor. Okay. And I have another processor called 8086. This internal architecture is different. What changes? The binary reading process will change, right? Or 8074. 74 is the old or 8086 is the advanced, I think. Alekia. No, Navnita, don't go for a bytecode because still I'm not telling anything about Java. I'm telling only about C++. Okay. So if I have a binary code generated here, understand this question carefully. Binary code generated on one processor called something, example I am taking 8085. Now, whether 8086 processor can understand that binary code? This is all happening in Windows only. Windows OS. This also Windows OS. Both are Windows operating system only. When you are generating bytecode, there are two persons involved in this. Your operating system and processor. Operating system and processor. When you are generating the bytecode, two persons involved in this, operating system and your processor. So if I generate a bytecode on the Windows operating system, that can be executed in any other Windows, but there should be a same processor available in that also. Okay, fine. Let me take a clear picture on this. Come back to this clear diagram. Now, see guys, I have my computer. This is my computer. My friend also having computer. My one friend also having computer. Another friend also having computer. So in my computer, Windows is there. My one friend having Windows only. My other friend having, okay, I'll take 4 guys then. I want a 4 guys. My one friend is having Windows, another friend having Windows, another friend having Linux. He loves Linux, he installed Linux. Okay. So what I did is, I have written a C program. We are talking about C, CPP, anything, both same, right? I have written a C program in my computer. I have written a C program in my computer and I compiled this. I got a hello.exe file. What hello.exe file contains? Binary code. When binary code generated, who are the two parties involving in this? Who are the two parties involving in this to generate this binary code? Who are the two parties involving in this to generate the binary code? I just now told operating system and the processor. Very good, Shravani. OS and processor. Now, I am taking, there is a X processor. There are names are there, let it be. Here I have Windows. OS is Windows. My processor is X processor. Some name I am taking. My processor is, guys, X architecture. For easiness, my processor architecture is X. Okay. Now, my other friend also having same processor. He also having same processor, X architecture only. My other friend having Windows operating system, but he's having different architecture. OS only, processor is Y architecture. And other friend, OS only changed. Maybe some processor is there, it is insignificant for us, whatever, let it be. It can be an X also, no problem. Listen the story carefully. So this is me, my computer. This is my friend one. Friend one. This is friend two. This is friend three. So I have written a C program in my computer. I compiled that. I got hello.exe file. And this hello.exe file, who helped me to generate? It is generated on the X processor and Windows operating system. This is generated on the X processor and Windows operating system. Now, my friends have asked me that you give me the program, we also will run in my machine. So what I did, I have given this program to my friend one. In a pen drive I given, consider as what I copied to my friend, hello.exe file I copied to my friend. I given the same to this guy also. And I given the same program to my other friend also. Okay. Now the questions for you. Where it will run, where it will not run. In which machine, in which computer, in which my friend's computer it will run, where it will not run, tell me. Will it run in all the places, all of my friends' machines? Where it runs? First, you take the one by one. Okay, take the one by one. F1. Will it run in my friend machine? Will it run in my friend machine? Friend one machine, friend one machine, friend one machine. Hurry, why you are telling no? Friend one is this, F1 is this is F1. See, me and my friend one using Windows operating system and same processor. Same OS, same processor, same OS, same processor, same OS, F1, same F1 and me having same OS, same processor. It has to run here, guys. It runs in. What about friend 2? What about friend 2? Friend 2, there is no big no, right? Big no, it won't run. Why? Why, guys? Different processor. Yes, it is processor depending. Binary code is processor dependent. Binary code is OS dependent, processor dependent. If you generate a binary code on X processor, some X operating system, or X processor or Windows operating system, that binary code will be understood by the X processor only on the Windows only. Another processor cannot understand because of the architectural differences between the processors. And what about my friend 3 is telling now? What my friend 3 will tell? My friend 3 processor X only, guys. I think, is it okay? Processor friend 3 using processor X, but OS is different. And there is big no here also, right? Big no there. So do you understand why why it is platform dependent? Is that clear? Whenever you write a C++ programs, whenever you write a C++ programs, whenever you compile them, you will get directly binary code. The binary code generated is OS dependent. Platform dependent means you have to use these terms always. It is OS dependent and processor architecture dependent. The binary code generated is OS dependent and processor architecture dependent. So if I generate a byte code in my computer on some operating system, on some processor architecture, I can't run this in all the computers because in other computers, they may have a different operating system, maybe a different processor architecture. That's why C++ programs are depending on processor architecture and OS, platform dependent. So is that complete story clear? Any doubts on this? So you have to take this diagram later. You take this diagram and based on this, the points I'm telling you write down. In interview, very important is two things important, guys. When you're learning things, two things important. Number one, understand the concept first. Understand the concept. Concept is super clear. Then second is you have to tell this in interview. For that, you prepare some sentences. You write down some sentences in your own and keep it ready by heart and keep it ready. Understanding concept in a clear way. Second is to reproduce this. When they ask the question in the interview, you have to reproduce it so clearly. So write down the simple English sentences, make it ready. That you can easily answer in the interview. Question from Ramesh. What's the difference between Windows and Linux? Windows is different. These are different operating systems. Different operating systems from different companies, right? Solaris another, Mac is another, Windows, Linux, Solaris from Sun Microsystems where I worked. Solaris, Macintosh from the Apple. Competitor are different products. Right? So is that super clear about why C programs are platform dependent, guys? Simple sentences I'm telling. If this question asked in interview, what answer I will tell is, when you write a C or C++ programs, we will compile first. When you compile, you will get a .exe file which contains the binary code. The binary code generated is depending on the current operating system, and current processor architecture. So if I try to run this in other computers, if the same operating system and same processor architecture is in another computer, I can run that. If you're trying to run this program in a different computer which has either a different operating system or a different processor architecture, it cannot run, because that operating system don't know this code. That processor architecture don't know this code. That's what it can't run. That's what it is depending on. Is that clear, guys? Right. So now, similarly, we'll do the Java also. Same thing, we'll do Java now. I will just change this to Java. Diagram will keep as it is. Small changes I will do. Okay, the question is, why Java programs are independent? This is independent. Independent of operating system, independent of processor architecture. Whatever the operating system you have, whatever the processor architecture you have, my Java program can run anywhere. That's what we have a sentence for Java as ORA. ORA means write once, run anywhere. Write once, run anywhere. So how ORA is applicable to Java only? Why Java programs are not depending on operating system, not depending on processor architecture? We will see the story here. So when you compile the Java program, what you will get, guys? I have written a Java program in my computer. I have written a Java program in my computer. After compiling this, what I'll get? I'll get a .class file, hello.class file, which contains the bytecode. Who is helping me to generate the bytecode? Who is helping me to generate the bytecode? Not only compiler, JVM also will help in this. JVM also will participate in this. Say compiler, fine, okay. Now I can run in my computer. If I want to run the bytecode in my computer, what I need? I need a JVM. If I have a JVM in a computer, I can run my bytecode. Fine. Now what I have to move to other systems, other friend computers. I'll move bytecode. Am I right? I'll move bytecode only here. I'm not moving I don't have any native code. Any native code I have in Java case? No native code, only bytecode. So I moved my bytecode to my friend 1 machine. See what is happening in the friend 1 computer. What happens in the friend 1 computer? What friend 1? Windows operating system, X processor. When you run this program, what happens? When run the program, what happens, guys? See, it is going to convert, your bytecode will be converted to binary code, am I right? Binary code, I am also using another term here, guys, native code. Can I call a binary code as a native? Native, N-A-T-I-V-E, native code means local code. local to that operating system, local to the processor. Now here I have my JVM, I have my Java compiler, I have a JVM. When I'm running my program, I am depending on the JVM. I am not depending on the operating system and processor, but I am depending on the JVM. When I'm running this with the help of my JVM, I am converting the binary code. Now I am generating binary code in my friend one machine, correct? I am generating binary code on this machine. Currently, what operating system? Windows. What processor? X processor. Now the binary code will be generated on the friend one machine according to the local operating system, local processor, so that this code will run in this processor and operating system. And again, when I'm running the same program, when I'm running a bytecode, here also I need a JVM in this computer. And here when I run this program, this bytecode, why again they generating into binary? This is the reason. Again, bytecode will be generated to binary. Again, you'll get a binary code here. This binary code is according to the current Y processor and Windows operating system. Temporarily, I am generating the binary code according to local infrastructure, local software, that is local OS, local processor. I am generating binary code there. I am running there successfully. And when I'm running on my friend machine where Linux operating system is there, so here also, again, I need a JVM. And JVM, it generates the binary code. In my friend 3, when I am generating binary code, guys, this binary code is compatible with the Linux operating system. This binary code is compatible with the X processor. So, are you moving the binary code here from one machine to another machine to run? In the C program, in the C case, what you have done? See, in the C case, you generated the binary code in one computer, which is local to that processor, local to that OS you generated. That code you are sending to other machines to run. So other OS may not understand, other processor may not understand. That's what we got a problem. But in the Java case, are you moving the binary code from one PC to another PC? No. You are generating the binary code according to the local infrastructure. I have first a bytecode. My file is .class file having a bytecode. So a bytecode I am sending to my friend machine. Bytecode I am sending to my friend machine. And there I am generating the binary code. When I am running the program in a friend machine, according to my friend machine's OS and processor, it is freshly generating the binary code there and running there without any trouble. And now, can I say write once, run anywhere? Can I say, guys, write once, run anywhere? I am running in one machine. Now, can I run this in any computer? Can I run this in any computer? Yes. Whether my Java program is depending on operating system? Whether my Java program is depending on operating system? No. Whether my Java program is depending on the processor? No. Where my Java program is depending on? You get any computer, no problem. Any processor, any operating system, no problem. You can run the program. But condition is you need a JVM there. You need a JVM there. So any of these machines, you get any computer. Your computer can have any processor, no worries. Your processor can have, your system can have any processor, no problem. Any operating system, it can be a Windows, Linux, Mac, Solaris, etc., no problem. You can run my Java program, but you need a guy, Superman called JVM inside that computer. If JVM is there, you can do anything. Right? Hari, question from Hari is whether all OS are having JVM? Yes. When you are downloading the JVM, when you are installing the JVM, we have a JVM separately for Windows, JVM for Linux, JVM for Mac. You have to get separate JVMs for separate operating systems. Okay? JVM might be different. JVM software is different for Mac, different for Windows, different for Linux. But once JVM is sitting in your computer, whatever program you bring, JVM will help you to run that irrespective of the underlying operating system and processor architecture you have. So Java program is OS independent and processor architecture neutral. Processor architecture neutral means neutral of processor, means not depending on the processor, not depending on the operating system. If you have my Superman called JVM, you can run the program anywhere. Next question from Pavani. Any real-time question on this? We'll see, Pavani. We'll see now. Nowadays, whatever we're seeing, many are there. We'll see that. On the way throughout, you'll see many scenarios. Okay, guys. So, do you understand exactly what is happening? So, any questions up to this? Any questions up to this? Any questions, guys, up to this? So, what we studied till now is, in this session, we are done how C program running internally, how Java program running internally, how the processor is working, and how the RAM will be utilized, and why C programs are platform dependent, why Java programs are platform dependent. 6 things we studied in this session. Okay? Okay, guys. So we'll see remaining in the next session.